leads us into the more general solution, which we've implemented at Google and which I will walk you through now. So first off, you need 3D models. We have them in abundance. If you played around on Google Earth, such as that image there on the right came from Google Earth, you'll get a feel for what Google has at its disposal. We've deployed 2 phones, 3D model assistants, for approximately 4,000 cities, covering all major cities in North America, Europe, Japan, Taiwan, Brazil, Argentina, Australia, New Zealand, and South Africa, and we have ongoing testing in other places not mentioned here. Next up, you have to have a means of doing ray tracing that's feasible. Now, if we look at, so here is downtown San Francisco, and let's look at it from sort of up in the stratosphere. The rays from the satellites look like this and looks fairly simple, but this picture on the left belies the incredible complexity that arrives in the labyrinth of the city. The picture on the right is the same picture as on the left, just zoomed in. And what you're seeing here are the actual rays that converge on a single location on the ground in the city. And so each bundle of the same color are the rays from a single satellite that find their way to a single location. So you can get an idea of the complexity by that. And from the numerics point of view, it turns out that if you have M satellites, so typically that's a number like 20, if you're doing this over N by N grid, where N here would be something like 100, and you have P rays. Now the rays here, when you're doing ray tracing, it's all the possible rays you have to consider. So P can be a very large number, like in the thousands. This problem is an order n squared P cubed computation problem. Now, typically with computing and coding, we try to avoid order n squared problems, like a nested loop is something you try to avoid. You definitely don't want order n cubed problems. This is worse than an order of P cubed computation problem. In plain English, this is not going to run in your phone if you don't do something quite smart to simplify the problem. So that's necessary in order to make this work. Some way of doing ray tracing that's more than just the typical and traditional way. And then you also need raw GNSS measurements, and luckily we've had that in Android phones since 2016. Many of you will be familiar with this, and you can get raw measurements from all GNSS satellites, and this is mandatory and standard now in all new Android phones. So the way we do the implementation is we use all of the above, the best of the published research. We're lucky enough to have worked very closely with some of those researchers I mentioned earlier. We also use our own Bayesian approach to deal with variations in the measurements, such as I've discussed. And most importantly, we use machine learning, which I will discuss in the next section.